Now we discuss Williamson synthesis, ether synthesis, stereochemistry of it. So question 1 is write on stereochemistry of Williamson synthesis. Second is SN2 mechanism. 1 degree alkyl halide favored it because it will undergo SN2 reaction more easily because of the less of the steric hindrance. Okay, now kinetics of it, and fourth one is limitation of Williamson synthesis and few of the example of it. Now we will go for this. Williamson synthesis or ether synthesis, what will happen? Alkoxide react with alkyl halide. So R what, that is ether will be formed. So one criteria you should know about it, that there are 3 types of alkyl halide. Primary alkyl halide, that is 1 degree alkyl halide or 2 degree alkyl halide or 3 degree alkyl halide. In this case, here RS1, 2, 3 I have written, that is a type of alkyl halide. It can be this or this or this. So it will favor 1 degree. This is 1 degree is favored for SN2 reaction. Reaction mechanism is SN2. So 1 degree is favored for this reaction. Okay, alkene formation will take in, because 2 degree and 3 degree will not favor this. So they will not favor this. Not favor ether, not favor ether. Ether not applicable here. Very mild is obtained in case, but otherwise more than 90% will get alkene with the help of 3 degree alkyl halide when we'll use. Now what will happen? Means this is alkoxide. I have taken simplest alkoxide, that is C2H5ON I have taken, and CH3Br. Okay, so we'll get C2H5OCH3, that is methoxyethane, or we can see methyl ethyl ether, ethyl methyl ether. In this IPAC naming there is no problem on writing. IPAC naming you have to write on methoxyethane, otherwise you have to write on ethyl methyl ether. Somebody is saying ethyl methyl, whatever you pronounce. Okay, now you are getting this, that there is a transition state. This is single step reaction because simultaneously bond breaking as well as bond formation takes place. This is a stronger bond between C and O and weaker bond between C and Br. So Br will be and secondly Br is better leaving group, so it will be cleaved very easily. Okay, so it will be cleaved from here. Okay, I have written wavy. Instead of black I will write on green, so it will be easily visible. So it will be break from here, and you will get, and this is attached from this C2H5O group is attached with this C. So now Br negative is cleaved. Right here I can write on minus Br negative. Br negative. Clear? Now inversion of configuration. See, just like an inverted umbrella. Because it is backside attack, so the groups are readjusted. So it is inversion of configuration takes place in this case. So this is biomolecular nucleophilic substitution reaction. Order of reaction is 2. Why it is 2? Because this is transition state and this is rate determining step. I will write down RDS, rate determining step. Okay, so I have written RDS so that you understood. Okay, rate determining step it is, and in this case, and this alkoxide as well as this both are reagents are present, and that is why it is biomolecular reaction as well as order of reaction is 2, because molar concentration of alkoxide as well as alkyl halide both are considered. With respect to metal alkoxide, it is first order reaction. With respect to alkyl halide, it is first order reaction. Overall order is 1 plus 1. So that is 2. Order of reaction is 2. So second order reaction means the concentration of both the reaction are considered and they determine the yield of the product. Okay, do you get all these points? Now we'll do the reaction mechanism. Write down all these things. Take a screenshot, or you can do yourself now also. Now we'll go for this. How to prepare diethyl ether, preparation of diethyl ether. Reaction mechanism I have written. See here, this is CH3, CH2Cl. I have written chloroethane for it, or you can say ethyl chloride. Okay, so and alkoxide uses sodium ethoxide. So SN2 mechanism I have written only, and then I made this, that there is a transition state. Here CH3, CH2Cl I have written this, and backside attack of C2H5O occurs and Cl negative will be cleared, kicked out. right? So this is the transition state. In this phase, both the nucleophile are present, bond breaking and bond formation both takes place simultaneously. So after some time it will be clicked out, and this OC2H5 will be attached to it. Now inversion of configuration takes place, and that is why we'll call it that this is SN2 reaction. When SN2 reaction, always inversion of configuration takes place. Inverted umbrella type structure will be formed. So products are here, diethyl ether, or you can say 1-ethoxy. See, 1-ethoxyethane. This is 1, this is 2. So this is called ethoxy. Or you can say diethyl ether or 1-ethoxyethane. Okay, so I have written somewhere here this 1-ethoxyethane. I didn't read. You write on your now. Yeah, I have written 1-ethoxyethane. Clear? Or diethyl ether. So diet and metal halide, that is sodium chloride, is obtained because whatever Cl is lost here, it will react combine with this Na positive and forms NaCl. Okay, so weaker nucleophile Cl negative is replaced by OCH3. Here OC2H5 or any alkoxy group, that is why I have written alkoxy, RO negative. Here in this case it is C2H5, OC2H5, so I have written ethoxy group. Is that clear? Draw these points and write down all these points. If you are missing something, then I will give you another information about it. Now you have to write down how can you prepare. Write down, I am dictating you. How can you prepare 2-ethoxy 3-methylhexane? 2-ethoxy 3-methylhexane starting from ethanol and 3-methylhexane to all. You simple think about it, because they are saying it 2-ethoxy 3-methylhexane. What does it mean? Alkoxyalkane is the for ether always. So you have to think about Williamson synthesis. So you have to write down alkoxide, alkyl halide gives you ether. This is the main reaction which is taking place here. And as I told you that we have to prefer alkyl halide, 1 degree alkyl halide. At that moment, what will you have to do? You have to take C2H5Br. Okay, and C2H5OH when we are taking, so first I am giving you general information, then I will go for another. So C2H5OH you have to give C2H5Cl. So here, see here, they have given from ethanol. Just wait. They have given ethanol and they have given second alcohol. Okay, so what do you think about it? How do you have to go for it? You must think that in previous time I also told you that 1 degree halide is preferred for SN2. So you have to, ethanol will give you 1 degree halide. So we have to convert this ethanol into 1 degree halide, that is C2H5Cl. Clear to you? Write on that. And after that we have to go for this. This 3-methylhexane to all, we have to react with it sodium, and we have to form sodium alkoxide from it. See here, I have done it here. Okay, so alkoxide is from 1 degree halide from alcohol, and alkoxide is obtained from this 2 degree alcohol, and then the reaction will proceed and we'll get the desired product. No need to worry about what is going on, nothing. You have to simply remove NaCl and put instead of this NaCl is out, so you have to write OC2H5. Reaction mechanism I already told you that this Na is cleaved, and then this will be attacking it from the back side. So you see, you will get C2H5O. CH3 C3H7. I directly written C3H7 so that you count 3, 4, 5, 6 carbon. Okay, so from here 1, 2, 3 methyl. So 3-methylhexanol was there. So we will get 3-methyl hexanoxide. Right, so I have not written here mechanism because I have given you the simplest one. You can try yourself, or simply remove Na from it and join with the alkyl group. So you will get the desired product. Right, now we'll go for the limitations of Williamson synthesis. Okay, I am giving you the way. Wait. Just wait. I am putting this on. Now, how can you prepare 2-ethoxy 3-methyl we have discussed this. Now I have to say you limitations. Limitations of Williamson synthesis. Tertiary alkyl halide undergo elimination in the presence of alkoxide. So we need not to go for that, okay, because it will go elimination reaction. Then alkyl halide and the sodium alkoxide, when you are using the ether is there, but di-tert-butyl ether cannot be prepared by it. What does it mean? Means both the group are having tert-butyl group, then alcohol ether will not be formed. This is the limitations, that di-tert-butyl ether cannot be formed here. Right now, CS vinyl group divinyl ether cannot be also formed here, because vinyl chloride does not give Williamson synthesis. It is very difficult to cleave Cl negative. Now, by SN2 mechanism on alkoxide is nucleophile that displaces a halide ion from an alkyl halide to produce an ether. If you remember this point, then only you will find out the correct answer. See here, I have written this vinylic halide, no reaction. Clear? Because easily ways of Cl will not be possible. So I have written no reaction, not applicable this. Clear? So you got that limitation. Di-tert-butyl we cannot ether we cannot make, or divinyl ether we cannot make. Okay, and thirdly, we should not use tert-butyl halide, because tert-butyl halide will give what? Alkene. Instead, major product will be alkene. Instead of ether, we'll get major product alkene. Now, Williamson synthesis here, tips of it. Ethers are formed, nucleophilic substitution occur, SN2 mechanism, order of reaction is 2, bulky halide undergo elimination, so does not prefer ether formation. SN2 reaction proceeds through a single step where the nucleophile performs a backside attack on the alkyl halide. So the big barrier problem for the SN2 reaction is steric hindrance. Okay, if it is sterically hindered, then it will the alkyl halide or the alkene formation is preferred over ether formation. So steric hindrance should be avoided. That is why 1 degree alcohol, 1 degree alkyl halide prefers this Williamson synthesis for ether formation. A positive charge developed on carbon atom attached to the hydrogen atom. See here, Cl is more electronegative than carbon, so attracts shared pair of electrons, so it will become a little bit electrophilic, and that is why the nucleophile will attack on it. Okay, and when nucleophile attack on it, then this Cl negative is kicked out. Clear to you? All the best. God bless you.